Very good morning, students. Today we discuss about in computer networks in protocol stack and the basics of packets. The last class we seen how the layered architectures are framed in that of using OSI architecture and TCP/IP model. Another in that of how to working the principles of methods in switching under virtual circuit and circuit switching. So now itself we see about the topic protocol stack. The first topic is a protocol stack. So first of all, the first class we seen about in layered architecture. What is layered architecture? The 7-layer approaches of developed in a OSI model, that is open source interconnection model. The set of each layers, that is 7 layer of physical layer, data link layer, network layer, transport layer, application layer. Session layer and presentation layer. So the 7 layers are working the principle of each such functions and methods using in a protocols. So the each layers are in the hierarchy model of the data are transferred from the application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. So the each layers are the format of data to be transmitted, bits, frames, packets itself. So in this approaches are called in a layered architecture. So that is purely working the principle of OSI and the TCP model, Internet Protocol and Transmission Control Protocol. So the each layered architecture under the one method that is called in a protocols. So the protocol is only communicate the each layer under the transmission of data from one layer into another one layer. So communication among the each other. So even the hardware and the software devices are shared and the resources are shared among the each layer under the principle of using in a protocols. So what is protocol? The set of protocols used in a communications network. So communications means the transmission of data to be shared among the resources from source to destination. So the network communications are used in the setup of under the rules and regulation, that is called in protocols. The set of rules and regulations are framed in each layer under the principle of OSI and TCP model. So what is a protocol stack? The protocol stack is a prescribed hierarchy of software layers and starting from the application layer at the top. So already I told that in the hierarchy of the layered architectures under the principle of protocols. So even in the protocol stack is a prescribed hierarchy. So 7, 6, 5, 4, 3, 2, 1. This is the prescribed hierarchy of data transmission in each layer. The starting from the application layer at the top. So the sources of the data being sent and received among the communication. So the data link layer at the bottom. After that, the bits of the data are transferred through in a physical layer. So this is the protocol stack explanation of communication among the network. So in this of layered protocol stack is a very good abstraction because of the each layered approach lets different protocols be swapped in and out to accommodate different network architecture. If it is example for OSI model, so the each layers are handled in different approaches of protocols in a different layered structure, isn't it? Okay. So the sending of application is a very simpler and to understand than open protocol. So the each protocols are how to send the packets in the applications of in a transport layer. The data are breaks, isn't it? Okay, so the easier to design, analyze, implement and test because of the data are the application where the applications are send the data to the transport layer. So the packets are breaked by the network. So it stores sequence number and other data in its header. So under the data to stored in the header. So it is a packet format or used in the protocol stack to receiving the data from the application layer. So the network layer adds source and destination data in its header. So which is defined in the payload of the data required to source address and the destination address of the port number, isn't it? Okay. So the data link layer, it adds station in a data, it's a header. The another in that of the corresponding layer, it reads the process of what are the data or discard them. So because of the data are transferred during the time can lost or corrupted the data, how to handle this one of the disadvantages of using in a TCP IP protocol stack. So in this protocol stack, is given good abstraction. Yes, it is strictly manner to exchange the data from one layer to another one layer, isn't it? Okay. So the strictly manner means how the data are handled in the each layer. So this is the design concept of using in a OSI model. Can you able to understood? Okay. So design model is a concept of a layered architecture. It means how the network interface and then how the internet formed, how the transport layers are working, how the applications are layer working. So the each layers are defined in the protocol. Is it means so? What do we mean by layers or layered by protocol? Okay. So now the next slide shown that in this manner, we take example in that of one army soldier. Okay, so it is define the protocol stack in a real-time example for in a general and then colonel, the captain, then sergeant and then private. So the each layers are working the principle of rules and regulation that is called in a protocol. So then the general given the instruction to colonel, the colonel instruction to captain, the captain from captain transfer the data that is in rules and regulation to surgeon, and then finally the data are very confident and then using in a private manner. Okay, so this is the how to you good understood in that of example. So so this is the minimized protocol stack using in a layered structure of TCP/IP model. So that is in a IP stack. So internet protocol stack. So internet protocol, this layer is correspond to the network layer. isn't it? Okay, so the layers are correspond to the network layer. This layer, it uses the IP address, and then IP address is consisting of network identifier and host identifier. It is determine the address of the devices. It is communicate with each other, isn't it? Okay, so each layers are communicate through in a layer. So the communications in internet protocol stack using the 5 layers of from application layer. The data are from we can get from the internet in system, application, transport, network, data link layer, and then physical layer. So the protocol stack using in the some of the protocols to development of in network based software systems under the principles of protocols. Okay, so the application it is a HTTP and then SMTP, FTP, using in a hypertext transfer protocol, simple mail transfer protocol, file transfer protocol. So these are the applications used network from in this network devices. Okay, so another in that of in a transport layer, it breaks messages. It breaks the messages into packets. So it handles things like out of order. The packets are very reliable to deal with the messages. Okay, so so the each layers are working the sorry, each messages are breaks into the packet. So it handles things in order to packets are stacked in a transport layer. Okay, so in this layer are handled the protocols are TCP, that is called in a transport control protocol. It works another device on the network. If it is it can able to accept the information from the local devices. Okay, the next one is in a network layer. The network layer is responsible for all the network interfaces. This layer, it combines the physical and the data layers and routes the data between devices on the same network. So in that of it manages the exchanges of data between the network layer. So the network interface using the some reliable routing algorithms. It easy to identify the best path when communication of the data from source to destination. The next one is in a link. How to sorry data link layer. So it is some data are formed in a frames. So the packets are moved in the type of frames. They take example in a local area network of Ethernet in a token ring and then topology. After that, they take the from the ATM machines. So the first layer of the physical layer. First layer of the physical layer, it is responsible for physically, that is moving the bits of the packet from one node to the next. Uh, that is from one devices into another one device. So the next slide. So the manufacturers are proposed in the periodic development of using in a protocol software into the family, and it gives you the some standard software tools, that is in a novel corporation, Banyan Systems, Apple Computer, Digital Equipment, IBM, and Internet Biggie, Netware, Venus, Apple Talk, DCS, NAT, SNA, TCP, IP. Okay, these and all the protocol stacks are used in each layer. So, how it is the principles of using in a internet protocol stack? So, see in this figure, the figure from the source to destination. Source to destination. So the each layer of the TCP IP protocol stack is 4 layers then that maps the each layer. So this layer corresponds to the network layer. If I take example in the internet IP address that consists of network identifier and a host identifier. So this is a layered structure of using in the internet. So the first of all in the top hub 1 and then hub n, that is n systems are connected through from the source to destination. What are the data are handled from one device to another some devices. Okay, so the first of all in the network interface, this is the layer combines of physical and the data layers and routes the data between devices on the same network. So the transport layer, the corresponding to the OSI transport layer, it is a part of the protocol stack where the transport control protocol, it can be found. Yes, it can be found asking some other acknowledgement from the each devices. One device is can respond to the any layer if it is willing to accept the data from some other device. So the application layer, it is a combines of session and presentation layer, isn't it, in the OSI model? So it is specific functions such as email, that is simple mail transfer protocol, and a file transfer protocol. It resides at the level of protocols are combined. So the developers are able to ensure that the certain level of compatibility is maintained, okay, in the from the source to destination. So we seen in this figure the internet protocol stack. It provides the connection oriented reliable branch, isn't it? Okay, so unless connectionless also support the in the UDP, that is user datagram protocol. So the both approaches are built in the top of the internet protocol. So in this protocol in the TCP IP, the first layer that introduces this virtual network, that is abstraction of the data from the one layer into another layer using the physical implementation. The physical implementation of the IP layer, it provides an unreliable, also connectionless delivery system. So why the reason why it is an unreliable system from the fact it does not any functionalities are having, that is error recovering or identifying duplication of the data and the loss of the data using in a remote host. So the basic unit of the data exchange using in a IP layer, that is called in a internet datagram. So also using in a UDP, that is user datagram. So in this important fields are included in that of each service of the layer, that is length and then types of service, what flags and then fragment apps offset, then time, source and destination addresses are mandatory how to attach in the top IP datagram. So the internet protocol stack using in the another one is a user datagram protocol, that is connectionless protocol, isn't it? Okay. So very over use of internet protocol using in the stop and wait protocol. So the stop and wait protocol, it is the simplest flow control method. It is sender to receiver from one frame at the same time to receiver. The sender will stop and wait the acknowledgement from the receiver. So the in that of stop and wait protocol, it is one of the error control mechanism. So in a connection oriented protocol using in the error control mechanism is used to receive the data should be it is divided into two categories. So stop and wait and then acknowledgement from the sliding windows. So the it is the protocol or how to be divided into two categories. So go back in and selective repeat. So based on the usages of the error control mechanism used in a stop and wait protocol and sliding window protocol. So such a manner in that of after sending the data, the stop and wait until he receives the acknowledgement from the receiver. So the stop and wait protocol is a flow control protocol, where flow control is one of the services of the data link layer. So the data link layer protocol, which is used for transmitting the data over the noiseless channels. So it provides unidirectional data transmission, which means that either sending or receiving of data will take place at that time. So it will be share the data from one place to another one place using in a flow control mechanism, but it does not provide any error control mechanism. So this is stop and wait protocols, how to acknowledge the using in a round trip. So the another one is a reliable pipelined protocol. So reliable pipelined protocol, So in that of pipelined reliable protocol is one of the data transfer protocol. The sender can start sending a data within a second before the sender receives the acknowledgement for the first data packet. So whether the acknowledgement is mandatory from the sender and then receives the acknowledgement. So if the sender needs to send several packets, so at the time when the last packet is received with the sorter with using in the pipeline protocol. So in that of reliable pipeline protocol is a very quick manner using in the better performance than stop and wait protocol. It is possible to measure the which in a pipeline protocol has been performance. So the stop and wait protocol, it is measuring the utilization or measuring the utilization of the connection on a link between the sender and the receiver. So so the pipeline protocol can improve the utilization when keep on tracking the sending and receiving the packets, whether the acknowledged for the earlier packets. If it is not at return, the packets are resent to the queue, that is using in a reliable pipeline packets. So this is the packet format. So dealing the transmission time, transmission have occurred the errors. So the methods are needing to determine if the packets are received correctly or not. Last the slide told that, okay. So this is the transport protocols of the internet using in a protocol stack. So that is the features and then what are the connection oriented, self reliable, and then data flow and then acknowledgement based windowing protocol using in the TCP. Then use the datagram protocol. It is a connectionless and then implemented to unregulated messages as in a datagram of using in acknowledgement. So how the messages are used using in this features, how advantages and disadvantages are there. So reliable, the messages arrives in order. So well believed due to the self policings are defined in the TCP protocol. Then UDP protocol is a simplicity. So it is find the data from communication to the environment. It is know the packets of lost data and error data to be identified. Then disadvantages is complexity occurred is unreliable, so complexity is not there. This is the transfer protocols on the internet. So this is the example for what are the protocols are used in the internet protocol. So in application layer using in the web browser protocol is TCP. The development of using in a Java HTML code, that using in a web browser of development in a web pages. The next instant messages using in a TCP. So it is a reliable message in order to arrive the messages. Then voice over IP, it is a low latency, the utility is having. Then electronic mails, it is a reliable, then TCP. Electronic file transfer, EFT, file transfer method is applying reliable, and then in order to delivery TCP, video over the internet. So using UDP and maybe TCP. So in this applications of using in a TCP, it is working in the file transfer networks. The network file works on LAN, that is local area network of using TCP and UDP. The last one is a branch retrieval using in the TCP IP model. So that's all students in a protocol stack. So in this concept, the implementation of using in a OSI model, how layered architecture are working using in a protocol. So the set of protocols are used to design the hardware and software oriented layered architecture. It is a hierarchy of model when the data is transferred from sender to receiver. So the next topic, basics of packet. So here in the top network packet, what is the so first of all, seeing about what is packet. So packet means the data or messages are divided into small pieces of data. It is called in a packet, isn't it? So So the telecommunication systems and the computer networking, so first of all, using in the network packet is a formatted unit of carried by the packet switched network, isn't it? So circuit network, another word is packet switched network. A packet is a consist of control information, isn't it? Okay. So and user data, the better it is also known on the payload. So the telecommunication systems and the computer networkings are formatted the form of network packet. So first seen about what is packet. So the networking packet is a small segment of it is a small segment of large message. The data sent over the computer network, such as the internet, is divided into packets. So these packets are combined by the these packets are combined by the computer or a device that receives them. So we have to take the example in a packet, how to write a letter to one person to another one person. We have to accept the envelope and the small index card. Okay, so writing the letter, it is trying to stuff through the mail slot. So it is divided into much shorter section. So small sections we have to divide it. We have to write a lot of things. Okay, this is a take in a real example how packets work on the internet. Suppose a user needs to load an image, it does not make. Okay, so we have to go for in a web browser. The images are broken into packets. That is wires, cables, and radio waves of the internet, and then reassemble by the users complete into the original data. So this is the basics of a packet. So comes upon what is packet networking. So the basic half unit information transfer over the internet. At each information is being sent off by sender is broken down into the small structure. It is enable the and easy quick transmission over the internet. So this is the definitions of given in a packets. A network is a group of two or more connected computers. The internet is a networks. So the multiple networks around the world that are interconnected with each other. Yes, the packets are interconnected using in a communication communicated as devices using in a interrupt manner. So the quickly becomes when two or more computers are involved, which is why long time to be processed using in a computer because the large data of packets are sent. Okay, so the internet is a packet switching network. The packet switching refers to the ability of networking equipment to process a packet is independently from each other. It also means the packets can take different network paths to the same destination, that is one or more destination. So the each packets are sent from the different destination using in a different solution from the multiple computers can travel over the same wires in any order. So so what is packet header? Before that, in use of packets, um, the packets switching in the network. The packet switching refers to the ability of networking to process packets independently from each other. It also means that packets can take different computer network paths to the same destination. So long they all arrive at the destination. So all the data arrive at the destination. It is used in the use of packets. So the same example for allies and the use. The data are transferred through in the internet. The packets consist of how two persons and using in the payload, that is a header and payload. The header is contains the information about the packet such as the origin and the destination. So IP address. So IP addresses like computer mailing address, the payload to the article, thousands of packets that make up image each other, which is posted in the data communication. So here in this slide, the packets are sent to the source to destination. The path is available, which is the best route of using in the algorithm, that is in the routing algorithm. The router there might be linked by all the all the other packets in the messages or by name of the other packets. So the first, the network can, so the network can balance the load across various piece of information on a multiple account to the transmission. So the depending on the type of network, it provides maybe some names, that is frame, frames and then block, cell and then segment, cell and segment. The packet format here in that of network packet structure. So the network packet the first of all is the packet header, totally 32 bits data. The packet header is labeled as header when provides the information about the packet's contents, origin and destination. The second one is a header that comes from packets actually has more than one header, and each header is used by different part of the networking process packet before the attached by the certain types of networking protocols. So in this protocols used in the computer can the data many different protocols making the internet work. So next packet format in the top trailers and footers. So packet headers are at the end at the front of time end of time the each packet. So routers, switches, computers and anything to see the data in a header first. A packet can also have trailers and footers. So some header and footers data are attached to the packets. Most of many attach headers. One example for network layer. So what is its an IP layer? IP layer is a network layer protocol having used doing a packet with the IP header can be referred to as an IP packet. An IP header contains important information about where a packet from one source to destination address, how large the packet is, and how long the network routers. It should contain to forward the packet before dropping. It may also indicate whether or not the visitor to the information about reassembling in a fragment. So what is packet and datagrams? So the datagrams is a segment of the data set over a packet switched network. A datagram consists of enough information to be routed for the source to destination. So by this definition, IP packets, one example for using in a IGMP, Internet Mail Transfer Protocol, this and all. So here in the network architecture header, the header information, it contains the instruction about the data carried by the packet. The length of the packet is length to be fixed while domain length while domain relay header to contain the first information. Synchronization and the packet numbers are specifically in the inner. So next one is the packet number. So in which of the packet numbers are represent how the packets are divided. So the protocol informations are the packet transmitted over the email and web pages. So determine how to determine to fill the data to be having in a destination address and then having in a port address. So this is the network packet structure. So here in that of network packet structure using in a trailer. The trailer sometimes called in footer. So header and footer. It typically contains a couple of that will do the receiving device and the receiving device that is reached the end of the packet. Okay, once the data is reached at the end of the packet, this is checking used in packets. The name is cyclic the common error checking and the packets in a cyclic redundancy check. So it is one of the pretty test. Here is now handle the errors during in the transmission of the data. So error checking. So the network traffic. In that network structure is also using in the network traffic because the packets are assembled and sent to the source to destination, isn't it? Okay, so how the network traffics are network packet. So the network traffic is encapsulated in packets in which the units of data that provides load in a network. For example, by visiting web page, user will receive the series of packets. How many hyperlinks are created in the web pages? We click the more web pages, automatically received the data. It is called in a network traffic. Is used in the series of packets. So the network traffic is referred as the data traffic, the amount of data which moves and access across the network during at any given time. So the network traffic is the amount of data in which moves across a network during any given time. Network traffic may also be referred as a data transfer using in a plain traffic. So if we take example in the top search engine, the network traffics are occurred in more specialized data are transferred from source to destination. So the paid direct traffic is occurred when someone enters the websites. It is using in the resource uniform resource locator. So in that of network traffic can be characterized as either being the client server model, the traffic that moves between the data center and the bottom at the location outside the network. That is in top to bottom and the bottom to top approaches the layered architectures or network. So the network traffic problems are ensuring the quality of the data. Yes, the accommodations of the data to be control network. So the administrators can control the network traffic through managing or protecting and monitor the network traffic by measuring the amount of and types of traffic. So encapsulated in a packets which are units of the data, it is provide the load network. If I take example in the web pages, the user will receive a series of packets. It is typically the packets will constant up to 1000 to 5000 bytes. So the visit the web pages can we can click the series of actions in using in a web link, isn't it? Okay. So the common network traffic is uses it is include the component failures such as a router or firewall failures. The traffic failures such as bottlenecks and high latency. The bottlenecks can occur when there is not enough data handling the capacity to process the current traffic. So ensure that the network quality of the network traffic, how to analyze and monitor and secure the network traffic, that is called network monitoring, will allow the cover cover side of your computer network terminal to network monitoring and visit commonly in a user manner. So if there are any significant or troubleshooting changes to the networking transmission, it is the performance of the network traffic. Why the network traffics are used? So the network traffic, it describes the number of network packets typing at the URL network at the given point of time. So given point of time, the network traffics are occurred in that of using in a manner. So that's all. The internet packets are how to working in a network packet. So the next session, question answer section. So this is the first question. The protocol data unit for the application layer in the internet stack is, it is in a PDU. So the protocol, sorry, internet protocol stack is used in the messages segment datagram frame. The frame is a data link layer, datagram UDP, then segment using in a data physical layer. So the application layer are only using the messages. Messages means the packets of the data to be transferred or divided into packets, isn't it? That is called in the option C is correct. Here the consider a source computer transmitting a file of size 106 bits to a destination computer over a network of two routers R1 and R2 and three links L1, L2, L3, this connected L1 connects to S, L R1, L2, R1 and R2, L3, R2 to D. So this represent in the figure diagram. Let each link be of length 100 km. Assume signals travel over each link at a speed of 10 seconds. So assume that the link bandwidth on each link 1 Mbps. Let the file be broken down into 1000 payloads of packets in each size of 1000 bits. Find the total sum of transmission and propagation delays in transmission the file from S to D, that is source to destination. So here in the top, the propagation travel is S to R1. How to calculate? That is a distance by link speed. The distance by link speed, that is 10 power 5 by 10 power 8, isn't it okay? So given in the top 10 power 8, yes, and then 10 power 5 is the distance between R1 and R2 using in a propagation time, that is reach the S to R1. So how to calculate the total propagation delay to travel from S to D, that is given the 3 into 1, that is 3 millisecond. So the total transmission delay in the packets 3 into number of bits to find the bandwidth of amount. So using in the 3 ms. So 3000 millisecond can reach the total sum of transmission and the propagation delay in transmitting the file from S to D. Can you understood the source and destination can take the propagation time, the formula of distance by link speed. The data is transferred to the signals from source to destination. So S to R1, R1 to R2, R2 to D, then D to S. So it's not a circular transformation of using in the data. So the data are transferred how to be broken into thousands of packets in a thousand bits. So the next question, an organization has a class B network and wishes to from subnets for 64 department. The subnet mask would be. So the size of the network ID is 16 bits, isn't it? Okay. So in the class B networks, the bits after 10th bit, so the it must be used to create 64 departments. So in this network of so total 6 bits are needed to identify 64 different departments. Therefore subnet mask will be 255.255.0. So whether you can check in your system, go to local area network properties. Okay, so here in the top have assembled the subnet mask numbers 255.255.252.255.0. Okay, so another one is having in the top assembled number in subnet mask. So class B network how to organize from subnets for 64 departments using the subnet mask of 255.255.255.0. So the next question, the N packet of switched network. The packets are routed from source to destination along a single path having two intermediate nodes. If the message size is 24 bytes and each packet it contains a header of 3 bytes, then the optimum packet size is. So given this question, the messages are divided into packets. So in applying network packet, it may decrease the transmission time due to parallelism, as transmission time to transfer 1 byte for all the nodes is said to be 1. So each nodes are said to be 1. The first packet will take the time packet size, and then the size of the packet have to represent 3 into d. The last class we seen in the how to calculate the time delay, isn't it? Okay, so propagation time plus waiting time w1 plus w2, so wait wt1 and plus wt2 using the waiting time. So that is 3 into t. After the first packet it reaches the destination, so that is the waiting time also calculated. The each packet it contains the remaining packets of the destination. Okay, it is represented in the packet size into 3 into t. So the remaining packets will take time equal to the packet size. So that is applied due to parallelism. So resend the packet in one manner to another using the weighting of the packets. So 3 power t, so 3 times the data are transferred in the packet size. So packet size is given in the figure is 3. So 3 bytes of the data header have to be allocated. So answer is 9. See this question, what is the maximum size of data that the application layer can pass the TCP layer below? So here in that of TCP IP header, so that is in the source address and the destination port address, payload, then identifier of virtual control identifier, isn't it? Okay, so the application layer can send any size of the data. There is no limit is defined by standards. So the lower layers divide the data if needed, whatever using in the top size. So the TCP IP header, how to define the limit of the data. So it is the limit how to be not calculated using if needed, whether the data is transferred from the application layer of using in a transmission of the data. So he given the size is any size of the data how to be defined. So more or less the in this question given the maximum size of the data to be transferred. So maximum size of the data is not to be defined. So limit of the data to be defined. So no limit of the data to be defined in the TCP header of payload. So totally in 32 bits of the data how to be transferred from one source to another destination. So option A, any size. Thank you, students. In this session we discussed protocol stack and basics of packets. The protocol stack, how layered approaches are using in a hierarchy of data model in the OSI and the TCP model, isn't it? Okay, the next in the packets, how network packets are organized and handle the data from host to host using some of the internal protocols are used in the application layer, the development of applications in the approaches of uh, computer networks. Okay, that's all. Thank you, students.